In the last lecture, we discussed which cost functions could be used for simple linear regression. But remember, their goal is really just to find the theta 0 and theta 1 values that minimizes our function. In this lecture, we'll learn about how we can minimize the cost function and extract the optimal theta 0 and theta 1 values. With that being said, let's get started. In order to minimize a function, we use an optimization algorithm. And while there exist many different optimization algorithms, the most fundamental one is gradient descent. And in order to introduce how gradient descent works, let's first see how a graph with two inputs looks like and how it differs from a traditional graph with one input. And let me get my pen out real fast. A graph with two inputs looks similar to this. And this is probably what you've been used to in the past. And this may be how a graph with two inputs looks like. And it's usually 2D. So a graph with one input is 2D. However, a graph with two inputs is 3D, as you can see here. And with that being said, now let's actually see how gradient descent actually works. So this is the first step to gradient descent. So first we guess a minimum value of And pretty much what that means is, remember that gradient descent is just an algorithm used to find the minimum value of a function. And in order to do so, our first step is to guess the prediction of the minimum value. So let's say the guess is over here. And now our second step will consist of moving the guess based upon the steepness. So in particular, if the steepness is positive, then we move to the left, and if the steepness is negative, then we move to the right. So in this case, because the steepness is positive, as you can see here, we move to the left. And we iterate this process until our guess doesn't change. And now let's actually formalize gradient descent. And as a word of caution, gradient descent, this formalization does require a little bit of calculus, but even if you don't know calculus yet, that should be fine. You'll still be able to implement gradient descent in a practical application, even without understanding the formalization of it all. With that being said, let's actually get started. So this is the equation for gradient descent. And this might look complicated at first sight, but this is actually much simpler than you probably think it is. So let's now actually see what each of these parts mean in particular. First, this theta j over here, that's just a parameter that we aim to train. So in this case, we aim to train theta 0 and theta 1. This colon equal sign is the assignment operator. And this pretty much signifies that our theta j value changes based upon a previous theta j value. So this assignment operator, in other words, just shows that our parameter value is changing. And that's why we don't use an equal sign, because that doesn't signify the changing theta j's. Now let's see what this means. So this over here, this is just the Greek letter alpha, and that corresponds to the learning rate. And in learning rate, it's pretty much just the step size of each of our steps. So going back to the graph here, if let's say we went from here to here, as opposed to from here to here, this over here would correspond to a bigger step size, and that would mean a bigger alpha. So pretty much, the learning rate is pretty much just the step size. And now let's see what this term means over here. So this is the derivative term. So this del j over del theta j is the derivative term, and it's used to measure the steepness. And as I said before, the steepness corresponds to which direction we moved. So if the steepness is positive, then we move to the left, and if the steepness is negative, then we move to the right. And we keep iterating this process until our guess doesn't change. And as stated earlier, gradient descent is just one optimization algorithm. and many other optimization algorithms such as nonlinear conjugate gradient method and many more exist, and they're sometimes even used over gradient descent. However, most of these algorithms are a bit over the scope of this class. And in fact, some people spend their whole lives working and developing these algorithms, even today. With that being said, thanks for watching this lecture and see you in lecture 5, where we'll bring all of these together and actually see what we need to implement simple linear regression. See you then.